Hi guys, today we're going to talk about the graphs of the tangent, cotangent, secant, and cosecant functions. This is log page 11 in your book. If I wanted to graph y equals the tangent of x, the first thing that I would do is go to my unit circle and get some points off the unit circle so that I could find the tangent of several angles. So I use these four angles, 0, pi over 6, pi over 4, and pi over 3. And I found their tangents off of my unit circle information, remembering that the tangent is the sine divided by the cosine. Then I took my periodic properties along with my unit circle and the fact that a negative angle is when I take the initial side and rotate it in a clockwise position. And so I know here that the negative pi over 3, that angle has a tangent of negative 3. Negative pi over 4 has a tangent of negative 1, and negative pi over 6 has a tangent of negative square root of 3 divided by 3. So I'm going to graph these points now and see what happens. If I'm looking at negative pi over 3, I see that it has a tangent of negative square root of 3, which is about negative 1.7. So here's negative 1, and negative 1.5, and negative 1.7 is probably about right here. The negative pi over 4 has a tangent of negative 1. So negative pi over 4, negative 1 is about here. Negative pi over 6 has a tangent of negative square root of 3 over 3, which is about 0.6. So negative pi over 6, about 0.6 is going to be right here at the bottom of my 6. And tangent of 0 is 0. Tangent of pi over 6 is about 0.6, square root of 3 over 3. The pi over 4 has a tangent of positive 1. Pi over 3 has a tangent of the square root of 3, which is about 1, 1.5, 1.7, so right about there. Now, the next thing I might want to ask is what happens at pi over 2? Well, you need to remember that the tangent of pi over 2, the tangent being the sine divided by the cosine, the sine of pi over 2 is 1, the cosine is 0, so if I do 1 divided by 0, I'm going to get an undefined slope. I didn't mean slope. An undefined tangent. Remembering from Algebra 2 that when you have something that is undefined in a function, that it's represented on the graph by an asymptote, a line that the graph approaches but never touches. Now think about negative pi over 2. That's the quadrantal angle that would divide the third and fourth quadrants. So on the unit circle, the tangent of negative pi over 2 is also undefined because it's the sine, negative 1, divided by 0, which is the cosine. And so I have another asymptote there. And now I can connect these, remembering that the asymptote is the line that this graph approaches but never touches. And so this curve is going to look like this. This is the graph of the tangent of x. I would like for you to know these critical points so that you can graph the tangent of x fairly accurately. I need you to know this particular period, remembering that the period, that we use capital T for period, the period of the tangent function is pi, not 2 pi. So from negative pi over 2 to 0 is 1/2 pi, and from 0 to pi over 2 is 1/2 pi. 1/2 pi plus 1/2 pi is 1 pi, which is the period of the tangent. Okay, so this is what it looks like. I don't want you to get the idea that this is all there is to the tangent. The tangent does continue to infinity in both directions. Okay, this particular period just repeats itself over and over and over again. I'd like for you to pause this video at this point and talk to your table partner about what happens for x as x approaches pi over 2, or as x approaches negative pi over 2, because of the fact that the tangent of x is the sine divided by the cosine. We've already alluded to this fact, but I want you to take a moment and reiterate this fact to your table partner so that we can make sure we've all got it. Characteristics of the tangent. The domain is the set of all real numbers, except for the odd multiples of pi over 2, because that's where your asymptotes are going to lie, the odd multiples of pi over 2. The range consists of all real numbers because my tangent continues to positive infinity and negative infinity. the value of the tangent approaches or goes to infinity. The tangent function is an odd function. That means it has origin symmetry. The tangent function is periodic with a period of pi. That means that it repeats the same period that you see before you every pi period. The y-intercept is 0, and the x-intercepts are negative 2 pi, negative pi, 0, pi, 2 pi, continuing on in integral multiples of pi. The vertical asymptotes will always occur at negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2. You're going to see that those continue. And I would like for you to discuss, when do you think that the vertical asymptotes would change? What would make the vertical asymptotes change from pi over 2 and negative pi over 2 to some other numbers? Pause the video at this point and discuss that with your table partner. All right, the cosecant. Move this paper. The cosecant. Here's the thing that I want you to remember about the cosecant function. The cosecant function is the reciprocal of the sine function. The cosecant function is the reciprocal of the sine function. And when you graph the cosecant function, what I want you to do is I want you to graph the sine function first. So I want you to graph your regular sine function. So hopefully from yesterday you remember and that the sine function starts at 0. It has a period of 2 pi. And then halfway in between 0 and 2 pi is pi. Halfway in between 0 and pi is pi over 2. And halfway in between pi and 2 pi is 3 pi over 2. And so we're just going to graph the sine function. 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, negative 1, and 2 pi, 0. And you can do this in a dotted curve if you would like to. I'm going to do it in 2 different colors here so that you can see it. Now, since the cosecant is 1 over the sine, anywhere that the sine is 0, you're going to have the cosecant being undefined. So if you will look, you'll see that the cosecant is going to be 0 right here at 0. So there's going to be an asymptote right here at 0. Because if the sine is 0, then the cosecant is 1 over 0, which is undefined. Right here at pi. If the sine is 0, the cosecant is going to be 1 over 0, which is undefined. And right here at 2 pi, if the sine is 0, then the cosecant is going to be undefined, 1 over 0. And then because the values of the cosecant are the reciprocals of the values of the sine, then what's going to happen with this graph is it's going to just flip up. The reciprocal of 1 is 1. Let me put another point on this graph so we can have accuracy here. The reciprocal of 1, because this is the point pi over 2, 1, the reciprocal of 1 is 1. If I came in here and found a value of 1/2 and took its reciprocal, it would flip up here and be 2. There's another value of 1/2, it would flip up and be 2. So what's going to happen is this shape is going to do this. It's going to have a U shape that approaches these asymptotes. Same thing's going to happen here. The reciprocal of negative 1 is negative 1. The reciprocal of negative 1/2 is negative 2. The reciprocal of negative 1/2 is negative 2. So this is going to flip over this way. The red graphs are the graphs of y equals the cosecant of x, which is the reciprocal of the sine. The same thing's going to happen with the cosine of x. All you're going to have to do here is start with your cosine, and you should by now know your cosine function pretty well. So we're going to take the cosine function, and again we're going to start at 0, and we're going to come over here to 2 pi. Halfway in between is pi. Halfway in between is pi over 2, and halfway in between is 3 pi over 2. Now, here's 1, here's 2, negative 1, negative 2. So my cosine of 0 is 1, cosine of pi over 2 is 0, cosine of pi is negative 1, cosine of 3 pi over 2 is 0, cosine of 2 pi is 1. And again, I'm going to do this in a dotted fashion. This has to be drawn every time. Okay, and then it's going to continue in both directions. Don't forget that. Anywhere that the cosine is equal to 0, here at pi over 2 and here at 3 pi over 2, then my secant, which is the reciprocal, the secant is the reciprocal of the cosine. So anywhere that the cosine is 0, the secant will be undefined, which means I'm going to have an asymptote there. So there are my asymptotes. And again, we're just going to be doing the reciprocals. So the reciprocal of 1 is 1, the reciprocal of 1/2 is 2, and over here we'd have another, this would continue, but I'm not really interested, I mean, you can do this other period if you'd like to, but you certainly don't have to. So this one we would do this way, and it is going to continue over here and make a U shape. The reciprocal of negative 1 is negative 1. The reciprocal of negative 1/2 is negative 2. The reciprocal of negative 1/2 is negative 2. So I get this U shape down here. And the same happens over here. The reciprocal of 1 is 1. The reciprocal of 1/2 is 2. And so I get another piece of this U shape over here. Well, that's not a very nice U shape, I apologize. And it would continue over here. You can see from the picture in the graph that it does continue in both directions. And if you want to draw more, you can. But this is the period that I am going to ask you to draw. Now remember that the period for the secant and the cosecant is 2 pi, just like the period of the sine and the cosine. Then if I want to do the cotangent, it's going to be the reciprocal of the tangent, which makes the graph flip. I'm going to put the tangent back here that I had graphed earlier with you. Here's my tangent function. And in red on this same graph, I'm going to graph the cotangent function. Okay, and I'm going to do just these critical points right here. Okay, I want you to look at this graph is what I wanted you to see. And what I want to do here is I want to make sure that you can see the differences in the tangent and the cotangent. Okay, the differences in the tangent and the cotangent is that the period is still going to be pi, but it's going to shift a little bit. Notice on this graph that the asymptotes are at 0 and at pi. Okay, and then we'll graph this function together. Okay, so let's look at this function. This is the cotangent. Okay, we're going to talk for a minute about why our asymptotes are at 0 and pi. Okay, the asymptotes are at 0 because the cotangent is the cosine over the sine. So at 0, my asymptote is going to go there because the cosine of 0 is 1 and the sine is 0. So 1 over 0 is undefined. And then we're going to come over here and we're going to see that we have at pi, we also have a cosine of 1 and a sine of 0. So 1 divided by 0 is undefined. And then we have pi over 2 here in the middle. And the cotangent of pi over 2 is the cosine over the sine, which would be 0, because the cosine is 0 at pi over 2, and the sign is 1, so that would be 0. And that pi over 6, I want you to remember right here, is the reciprocal of the tangent, okay? And the tangent of pi over 6 is the square root of 3 over 3, so the cotangent is the square root of 3, which is about 1.7. So that's going to be 1, 2. So that's going to be here. And the same thing's going to happen that happened earlier with the others. We could just go ahead and graph them, but I'm just going to go ahead and sketch this in because really what I want you to do is to see how this flips around. Pi over 6 is going to be square root of 3. Okay, so this is the cotangent. Y equals the cotangent of x. And it looks a lot like the tangent of x, except that it is shifted over. Its asymptotes are at 0 and pi because of the fact that it is the reciprocal of the tangent. And it also starts on the left side coming from positive infinity. The range comes from positive infinity down to negative infinity. This is the piece of the tangent function that I want you to graph. And I'm going to take any questions that you have on these graphs during class today.